Hello, I'm going to do a problem on the Doppler effect. And I'm going to do two actually in two separate videos. So this one is going to be with two objects, and the other one's going to be a little more interesting one because it has only one number given. So this one, we've got a problem with two moving objects. A westbound train has a speed of 72 meters per second when it blows its 610 hertz whistle. An eastbound train on a parallel track is approaching the other train, and its engineer hears a 920 hertz sound. What is the speed of the eastbound train? So problems, good problem solving strategy, draw the picture. So we have a westbound train going this way, and we know it's moving at 72 meters per second, and it blows a whistle at 610 hertz. An eastbound train on a parallel track going this way hears a 920 hertz sound from this one. We want to know what is the velocity of the eastbound train. All right, so there's my general picture. And when I'm doing Doppler problems, one of the things I like to do is make very clear in my head who's the observer, who's the source. So in this case, this is the one who's hearing the sound, so this is my observer. This is the one making the sound, this is my source. The source is moving, the observer is moving. So in this case, I've got a moving source and a moving observer. And a moving observer. We have different equations for these two, and the physics is different for why the sound changes because of a moving source and a moving observer. And what I need to figure out as well is direction, because the equation for a moving source is different if the source is moving towards the observer or away from the observer. In this case, it's pretty clear the source is moving towards the observer. So moving source, moving towards. The observer is moving towards the source. So we've got this. And now the source equation, the observed frequency is the source frequency for a moving source. It's 1 over 1 plus or minus V source over V sound. And then for a moving observer, we've got observed frequency equals source frequency 1 plus or minus V observer over V sound. Now you can do these problems in two steps where you do this to get the frequency shift because of the moving source, and then put that new frequency in here for shifting the frequency because of the moving observer. But you can also take a shortcut. You can take a shortcut by putting these two equations together and doing it all in one step. So in one step for a moving source and a moving observer, you just slap these two together. They both start out with FO, they both start out on the other side with FS, and then we have this on top, this on bottom. So I've got 1 plus or minus V observer over V sound, and then on the bottom, 1 plus or minus V source over V sound. And if you want to write this on your equation sheet, this combined one, you go right ahead. So in this case, I know my observed frequency. So that's the observed frequency, the heard frequency. This is my source frequency. This, 72, this is the velocity of the source. And we want to know what the velocity of the observer is. So I know that. I know FO, I know FS. I'm wondering what this is. I know the speed of sound. I don't know the speed of the source. The only thing I need to figure out at this point is which sign to use. Am I going to use the plus or the minus up top? Am I going to use the plus or the minus on the bottom? This is where we have to think about this. Now moving towards, it doesn't matter which is moving. Moving towards always increases the frequency. So for a moving source going towards, we want the frequency to go up. So that's the bottom part of the equation. I want an increase in frequency. So I want this number to be multiplied by something big. To get a bigger number, you divide by a smaller number. So in this case, I'm going to choose the negative sign. Because if I have a bigger number on bottom, that means I have a smaller number on bottom. That means I have a bigger number on top. Yeah, you got to watch your language here. So a smaller number on bottom means overall we end up with a bigger number. And towards means we want a bigger frequency. The frequency increases. For a moving observer, towards, we also want an increase in frequency. And this is the top part. So here, what am I going to do, a plus or minus, in order to make a bigger number? Well, in this case, I'm going to add because we're on top. So I'm going to have a bigger number on top to increase the frequency, a smaller number on bottom to increase the frequency. And now I've got it. I just have to throw the numbers in. Here, I'm looking for this. So I need to get this alone on one side. I'm going to take this whole term, pop it up to the other side. So F observed, 1 minus V source, and I'm just going to start putting 345 in because it's easier than V sound, equals F source 1 plus V observed over 345. I'm trying to get that alone. So divide both sides by F source. FO over F source, 1 minus V source over 345 equals 1 plus VO over 345. Okay, this is getting messy. I'm going to start throwing some numbers in here. You can go one more step, divide both sides by 1, multiply by 345. Just going to throw the numbers in at this step. FO is 920. Source frequency was 610. 1 minus V source, 72 over 345, equals 1 plus V observed over 345. So if I do all this, I end up with 1.19. And now here, I would suggest keeping decimal points out a couple more because that's really close to 1. And I see that I have 1 here. I'm going to keep a couple more decimal points out so that I have a better answer. 345. Okay, so now I'm subtracting 1 from both sides. 0.1934 equals VO over 345. My observed speed, the speed of my observer, is 345 times 0.1934, and we get 66.7 meters per second, which is really fast. It's like 130 miles an hour. Is that reasonable? Well, look at the speed of the source, 72. These are very fast-moving trains. So if we have this train moving at 72, 68, 67, seems reasonable for this one. And the units are right. I don't see that we probably made a mistake. We have a reasonable answer. We answered the question, which is how fast is the observer moving. I think we've got this one. All right. In terms of common mistakes here, you can probably guess that the most common mistakes made for Doppler problems are the signs, are getting the signs wrong. If you struggle with which sign to choose, just do it in one step and do both of them. Do 1 plus V source over V sound, do 1 minus V source over V sound, and choose the number that makes sense. In this case, we need towards, which means an increase in frequency. So if you do both of these, choose the one that's higher than 610. Same thing here. Once you know that number, you can do the same thing here and say, oh, okay, well, I'll do plus and I'll do minus and I'll pick the one that makes the frequency go up. So if you struggle with remembering the signs or being able to figure out the signs, do both and pick the answer that makes the most sense. Other than that, I think we've got this one done. All right, good job.